Now let's look at the vector format and how it differs from the raster format. Now I'm going to talk about vector graphics. Here are 3 examples representing the range of complexity that you can get in the vector world. First of all, the background of this slide is a vector graphic. Those crisp, clean lines give it away, although the fade-out effect in the middle is something that is not easy to do in a vector program. The swipe bar down from the top right corner is a classic use of gradient, which is very common and easy to do in vector graphics. Bending the text you see here is also quite easy to do, since, as I said before, text characters are actually just little vector objects. They can be squeezed and shaped any way you want with no loss of quality. The graphic on the upper left is just some abstract shapes sitting on top of each other. This is a very simple representation of the geometric nature of vector graphics. As with the swipe bar, notice the use of gradients in the shapes. These are the smooth color transitions filling the shapes. The clip art below it of a beach scene is getting a little more realistic, but it's still very obviously a drawn piece of artwork with discrete shapes in it. The last graphic is on the high end of complexity and realism for vector graphics. This took someone a long time to draw in a program like Adobe Illustrator. However, it's still obviously synthetic and cartoonish. It's not even close to a real photograph. The background and all the slide titles in this section are vector graphics, by the way. Vector graphics are mathematically defined using geometric formulas, and they're composites of independent shapes. You can bend text as you saw in this and the last slide. There's no rectangular bounding box like there is in raster graphics. In raster graphics, if you don't see that bounding box, there has to be an alpha channel identifying the transparent areas. But in vector graphics, there is no bounding box. The border of the shape defines the edge of the object, whatever it is. This image of the Renaissance man is obviously a synthetic drawing, not a photograph. Like the man holding a basket of fruit in the last slide, this is somewhat at the higher end of what you can do with vector tools like Adobe Illustrator. People are going far beyond this now with things that are actually fairly lifelike, but you can usually tell that they're not photographs. Why would you try to do something as a vector graphic when you could just use a raster photograph? Well, cost. Like I said in an earlier slide, vector drawings don't require paying models and mocking up scenery. The 2 lines of code pointing to the button on this guy's coat are actual vector code that is generated behind the scenes in Illustrator to create the button on the guy's coat. It says to move the cursor to a point on the screen defined as 200 on the x-axis and 200 on the y-axis, and create a circle with a radius of 20 pixels. The beauty of this is that if you wanted this button to be bigger, you just change the number 20 to a bigger number, and the computer will draw a bigger button instantly. That's all you're doing when you resize a vector graphic. You never actually see these numbers, of course. The program creates this code on the back end as you draw with a mouse. To make the button bigger, if this was a raster graphic, you would be changing lots of color numbers in a grid of pixels. Which pixels get changed and in what way gets very complicated very quickly, as you can imagine. You'll learn more about the implications of this later in this unit, when I'll be talking about pixel dimensions and pixel density. Here are the most common vector file types. They're all metafile formats, so you can mix vector artwork and raster images together in them. Vector format is resolution independent, unlike raster graphics, which are resolution dependent, which means that there's no resolution setting you need to worry about when you're creating vector graphics. A vector graphic will print or display at the highest resolution the output device can handle. So you can blow it up to the size of a billboard, and it'll look totally clean and pristine with no pixelization. Here are some of the more popular vector graphics tools. All of the programs you see here work equally well for web and print. There are lots of 3D effects you can do in the vector format, as you can see here in the title of this slide. This is mainly due to the fact that the vector format, like 3D, works natively with geometry and objects instead of pixels. The title on this slide may look like it's a raster object, but this is the result of applying state-of-the-art vector effects to type. Since these text characters have been retained as vector objects, they're fully editable as ASCII text in a vector program like Illustrator. I've already talked about a lot of the points I'm going to make on this slide. This is a summary. Vector artwork is resolution independent. In other words, it's not dependent on things like pixel dimensions, pixel density, and physical size. In fact, the concept of resolution doesn't apply, since you're dealing with geometric formulas that create as many pixels as needed on the fly. This means that the artwork can be scaled to any size without any regard to loss of quality. In fact, the computer will always render a piece of vector artwork at the highest resolution the software and computer can handle. This is completely different from raster images, where resolution, especially pixel dimensions, defines an upper limit as to how much you can resize without image degradation. You can't get blood out of a turnip. If you have a low resolution image, that's what you're stuck with during the entire editing process. This cartoon definitely shows a graphic artist who's working with vector artwork. The woman is saying, of course they always tell you to make changes because you always tell them how easy it is to make changes. But the point is here that you're dealing with discrete objects, not grids of pixels. It's just inherently much easier to deal with, especially in terms of resizing the artwork. Versatility in manipulating type is a very important advantage. That's because type characters are inherently vector objects. But if you put type inside of a raster image, it becomes part of the image. It loses its identity as ASCII text, as I talked about in the typography unit. Here's an example of this. This type has been embedded into this white bar, which is a raster image. It cannot be selected and edited anymore, because all the image knows is that there are some dark blue pixels inside of this white bar. The file size of a piece of vector artwork is a very small fraction of an equivalent raster image. This is because on the raster side you have to define all of the color numbers for the pixels in a rectangular grid of them, and there can be thousands of them. Whereas, as you saw a few slides ago with the button on the Renaissance man's coat, on the vector side you're just dealing with mathematical formulas and letting the computer create the color numbers on the fly. With vector artwork, you get crisp, clean lines that the computer draws to the best of its ability at the highest resolution it can handle. This orange square is a perfect example of this. Here you see it scaled down to a small size, and here you see it scaled way up. Now you can see all the detail in it. It's actually a very complex and very busy piece of vector artwork. The great thing about this also is the file size is exactly the same, whether it's this big or as small as it just was. All that has changed behind the scenes is a few numbers in a formula. Cost considerations nowadays are driving professional graphic artists to use vector tools to create images that are pretty lifelike. It's very time-consuming to do this, and most of the time they do look somewhat artificial, but there can be great cost savings from doing this as opposed to hiring models and staging sets to compose a raster photographic image. Here are the disadvantages of vector format versus raster format. Perfectly straight lines are rare in nature, but that is what vector artwork does best. So vector artwork does not lend itself to naturalistic graphic compositions. Continuous tone images like photographs are very difficult to simulate using vector tools. A few brave graphic artists have done it, but it takes enormous skill and time. Needing to rasterize anyway for web and animations is not really a disadvantage, since it's so easy to rasterize a vector graphic, as long as you keep the file in vector format for as long as possible to maintain maximum editability. The eraser tool and pencil tool shown here are key editing tools in raster graphics software. They allow you to edit individual pixels or small groups of them. You can't do that with vector tools unless that group of pixels is defined as a separate object.